In this video, we'll look at question 41 from the specimen paper. This question wants us to find the number of real solutions of this equation. And the way we'll approach this will be slightly unusual for this kind of question. We'll start by differentiating the polynomial in order to find its stationary points. So when we do that, we get 4x cubed minus 12x squared plus 8x must equal 0 in order to get the stationary points. And that factorizes nicely to x minus 1 times x minus 2 times x equals 0. So we have 3 stationary points at 1, 2, and 0. And we see that the value of the original polynomial is negative at all 3 of these points. It's negative 9, negative 18, and negative 10. So that's one fact we'll use, that the value of this polynomial is negative at all 3 stationary points. And one additional piece of information to note is that the whole polynomial goes to infinity as x goes to both positive and negative infinity, because this term here will take over. All the other terms will be negligible, and we have an even power, which means that even at negative infinity, we get positive infinity. So how can we make use of all this information? Well, first of all, we know that for extreme x's, the value of the polynomial tends to positive infinity. Moreover, all 3 stationary points will be below the x-axis. They have negative values associated with them. There are no other stationary points whatsoever. The only way to connect these 3 points with the 2 parts of, the 2 lines involves crossing the x-axis exactly twice. That means 2 roots to this polynomial, 2 real roots. Every other possible path would add minima and maxima another few stationary points, which, however, as we see, aren't the stationary points of the original polynomial, and hence those are all wrong, and this is the only possible shape. 2 real solutions means that the correct answer was C.